All right. Hello, everybody, and welcome back to TLC, Tom and Lonnie Chat. I'm Dr. Tom Kerfus from Georgia Tech. We've got the ever knowledgeable and engaging Dr. Lonnie Love from Sandia National Laboratory.
Hey, Tom.
Hello, Lonnie. And of course, friend and constant guest, not even guest, he's like a family member now of the podcast, Stephen Lamarca from AMT.
Hey,
How
guys.
you doing there, Stephen?
Doing well. How are you guys on this beautiful Friday?
Great. Oh, just peachy, as we say here in Georgia. I love the backdrop over there. So, and we've got returning to the podcast. We've got Russ Waddell, who is going to be talking to us about some cool stuff today. I think we might actually kick it off. I think, I'm a parent. Actually, now I'm a grandparent, so I'm getting up there. But as a parent, you often wonder about your kids and they're playing video games and the whole bit, and you're like, so is this really good? Maybe they should be studying as opposed to be playing video games or doing something else. But maybe, just maybe, playing all those video computer games might give them a skill set that could help them out in their career. And I think, Russ, are you here to tell us about how that might work? Probably not. I'm just sort of giving you a funny intro. But there's some interesting similarities and synergies there. Russ, why don't we turn it over to you?
Well, I think my parents shared your optimism that spending a lot of time on video games would lead to an illustrious career as a software developer. And that clearly didn't work at all. So maybe things have changed in a generation. So my kids, who are now pretty hooked on mobile gaming, they want to play Roblox, but I won't let them. Minecraft is big. Xbox, Switch, all of it. It's just constant. There's never-ending video games in our house, which is okay because I never really stopped playing video games, so it's fine. And it's a great way to bond. So I think the idea that you are going to play video games as a kid and grow up and become a game developer is sort of like saying that you're going to play Parcheesi as a kid and grow up to like win in Vegas. So I don't know that it fully translates. But I do think the upside is kind of if you pivot it to general digital literacy. So can I work a computer? Can I naturally want to go connect with other people? Am I going to be able to understand, what's a server? Why do I care about a server? What's the difference between the server, my laptop, my mobile device? What's the difference between a cell signal and Wi-Fi signal, something like that? And in manufacturing, a lot of people who are still in the workforce didn't grow up with any of that stuff. So there's I wouldn't say it's a divide in the sense that there's a hard line, but it's more of a continuum. And it's only becoming more of a gap between sort of the newest people coming into the industry who are not just digital natives, but they're native to sort of the digital trends of the last 15 to 20 years. And that things have changed really fast. So I don't think that your optimism is well placed, that parents of video game kids will go and save the world by becoming software developers. But I do think that there are major demographic trends that are impacting manufacturing.
Well, so Russ, I think what is interesting is back in the 70s where the personal computer started really coming out. I don't know if people really at that point in time, maybe some visionaries did, but saw the impact that the personal computer could have and in terms of manufacturing. And what I think is interesting now, we were talking about this before the show, is the growth of the gaming industry is enormous. And the expectations and the demands are enormous, and it's driving a lot of innovation in terms of computing, in terms of visualization, in terms of communication. So I'd love your thoughts on the gaming industry and where it's going, and what your thoughts are on how the manufacturing industry could leverage it.
So this has kind of been like a personal quest. I suppose if you want to put it in gaming terms, it's a quest. It was maybe 10 years ago that I saw the first use of Unity and Unreal Engine. So these are game engines, which means that it's software that makes software. It's the environment that you work in, and then it runs the game itself. Unreal Engine is named after the game Unreal. Unity is kind of its own thing. And in both cases, you'd see these laboratory or university research and experiments that were basically like, oh, I've got a mobile robot, and I'm gonna put some vision system on it where it's sensing its environment, and then I'm gonna map that out in this virtual 3D space. And that was done with the best in class tools for showing a visualization of 3D space. And that happened to also be the tools that are used to make a video game. Right. So that sort of put this thing on my radar, and I was sort of curious about it. And it's been in the back of my mind for a long time. Until, and I think I mentioned this before we got started. There was a video I saw. This was way after the introduction of Unreal Engine and way after the first time I'd seen an industrial use case for the Unreal Engine. I watched this video that was basically just a tech showcase for, here is what the Unreal Engine 5 can do. And this was now at least 5 years ago. And the amount of nerdy brain power going into exactly how one stone that falls off a cliff is, reverberating through this canyon, or the wind in a blade of grass, or, what it looks like when someone moves and their hair is moving. And I'm like, okay, this is an enormously great amount of detail. But oh my goodness, the amount of technical effort and brain power and thought and coding energy and developer energy, and it's all going into these things that are kind of window dressing, right? It's not that I have a problem with good looking video games, but what if we took the same energy that's going into that and put that into CNC programming, or path planning for a machine tool, or better look ahead functions, all these other application spaces that I couldn't help but think the main reason nobody's working on that in our space, in our domain, was that there's just not overlap between the people that know how to build stuff with a video game engine and people that know about a factory floor. So that's kind of been a specific project. And for the last year and a half, I've been actively working on kind of exploring that market, understanding what's coming next, how it relates to my past work with MT Connect and my, crossover with Dr. Kerfus and these kind of things. So that's the short version. I don't know if that really answers your question, Lonnie.
Yeah. Yeah.
But I mean, and there's so many synergies if you think about it. When let's just say a sort of a first person or perspective game, and you're running around, right? And there's a wall in front of you. You hit the wall. Okay, well, you hit the wall, and that's it. Now instead of you're running around through some force and hitting a tree or a wall, you're a boring bar, and you're inside a tube, right? And now bang bang bang, right? I mean, there's a wall there, and so I mean, I get it, Ross. I mean, the cool thing is all the same stuff that you see, in these video games are, same, collision avoidance. Don't hit the tree.
That's right.
Don't hit the tooling. Don't hit your fixturing, and so forth. And with, I think, some pretty good digital twins, at least on machining. And I know you're talking even bigger stuff, but a lot of the machines now ship with digital twins.
That's right. Yeah.
And so it's beautiful.
So if you look at the IMTS 2024 last fall, you could see a large number of machine tools had some variation of what would kind of be under the umbrella of digital twin, typically on the controller. So what I was there specifically scouting for, as I look at these controls, can I see some sort of real time or near real time or live video or rendering of what's going on in the machine. So I'm a little bit hesitant to use digital twin because you get into like a definitional runaway.
Yeah, I know. It's overused.
And real time doesn't quite apply if we want to be concerned about determinism. So really what we're looking at is it's a near live visualization is really the thing I was on the lookout for. And what's crazy is there were a lot of controllers that had some sort of digital version of what was happening. So it looks like the machine and the axes are moving and it's going to show an alarm if there's an alarm. And that's in this little window on the HMI. What was maybe the most surprising about this was how much variation there was from one machine to another. So a lot of places had this existing. In some places it's just plain lines. In some places it's surfaces. There's no easy way to tell from looking which ones have sort of a robust model for kinematic included, or how much physics is actually being simulated in there. So all that stuff, you sort of have to start asking the people that, at a show like that, or when you're talking to an operator, it's like, what do you know about the control? And then you kind of go down this path of breadcrumbs trying to figure out, well, who's the small team at the controls manufacturer, maybe not at the builder, that was responsible for this feature. Was this a show special where it got rolled out as a tech demo, or is this, fundamental to the next generation of the tool? And, it was months and months after that where I was taking these examples that I was seeing and looking for, what's behind them, what's the meat going into it, how much model is really there. Steve, I don't know if you remember this conversation maybe a year ago. We were talking about, do you model bullets generically, or do you model every bullet for a first person shooter? Do you remember this?
Russ talking about that. Yeah. But it makes me, because of the earlier conversation we were just having, talking about, when you're playing a game, the game knows when your character is about to run into a wall. And you don't want to run into the wall, obviously, but the wall also needs to stop you to keep you from going through it. In gaming, that is called clipping. And it's funny to talk about this because, it's 2025 in the manufacturing industry. The CAD CAM software, if not implemented properly, will still let the machine tool try to clip through its workpiece. Have you noticed in all of your recent work with this crossover between gaming and in the manufacturing industry, have you noticed any other technical jargon from gaming crossing into manufacturing and vice versa?
Well, I know not recently necessarily, but I remember one of Dr. Kerpus's advisees was working on voxel-based CAM. So a voxel is a three-dimensional pixel, and the crossover there is the game being built in three-dimensional pixels, or is it being built in two-dimensional pixels? Are those pixels conceptually three-dimensional, or are they actually modeling a real-life thing? How much does it matter? So like clipping through a wall or running through a wall or failing to run through a wall, you end up in this modeling question like the bullet thing. What your example was, a gun in a video game, machine gun is shooting, bullet casings are flying out. Do you need to model every single casing to know where the casing is going to fall? And how much do you need to know about that casing? Do you need to know what it looks like? Do you need to know what it sounds like? Do you need to know about thermal expansion? And is that generic? Or do you just draw a picture of here's a line coming out from the thing? Because for a game, ultimately what you're looking at for something like that, where it's really not fundamental to did my bullet go at my target? It's really, this is, exchanging cartridge or expelling cartridges it's just part of the general realism of looking that way. And in manufacturing, like, I don't know how much we care about the realism of looking a particular way, but if it comes down to, how something behaves, now we care a lot about it. So how does material deform? How is a chip created? And then I'm more concerned with things like, well, now I really do need to have some model for thermals for the material itself, thermals for the cutting tool. That stuff all is important as a part of, the set of models that make up my digital twin. Whereas in the game, I don't necessarily care how hot the bullet is if it comes out looking right. And, I've programmed that dot goes from here to here and, yay or nay on the target, triggering the next piece of the code. You know what I mean?
Yeah.
Right.
Yeah.
But I'm sorry. In like, like a first person shooter that you're probably describing, the firearm physics and the terminal ballistics of a gunshot. I think a lot of that physics is like, the next level. The manufacturing industry wants to be there with like, predicting tool wear in a digital twin. Sorry, I said it. In the thermal expansion properties. But I think going back to like the crossover question, I think a lot of the excitement that the industry is getting is coming from actually an NVIDIA. I don't know if it's an NVIDIA product or just a term that they've coined, but that gamers are really familiar with and they've been talking about for like the last 10 years, ray tracing, which is really popular in modern GPUs, or at least has been since the NVIDIA RTX 20 series, which is now old. But ray tracing is the physics of light and how rays of light in your game or in your engine travel through different medias, how they refract through those medias or birefract in some cases, depending on material, which is something the manufacturing industry cares about, or in some cases reflects off of. And a lot of that processing power on these more modern GPUs is important because the GPU has to be able to render the existence of that light off screen. And I think the really techie people in the manufacturing industry take that gaming tech and get really excited about that because that is physics, and it's right now it's just being applied for visuals and light. But I think, like you mentioned, the end game is to apply it more to the dynamics of how a tool at speed and at temperature interacts with the workpiece.
Well, I would say even simplifying that, because again, the ray tracing and where the light goes. I mean, you think about it, that's sort of okay. Hey, light's going to go through the wall. It's not, so I kind of know where the wall is reflecting off. But you're right; it's sort of the physics thing. I think about it, for example, when you take a look at, now you can enhance your models. So, for example, I think we all know that something like a ceramic insert doesn't like interrupted cuts. And so, if you're not thinking, right? I mean, one of the things you could do is your machine may say, okay, I know in my tool holder, tool holder TL101 has got a ceramic insert in it. And now I'm running this part, which has got a slot in it. And all of a sudden I am going to have, let's say I'm turning, I'm going to have an interrupted cut. And so, on a very simplistic basis, it can come back and say, oh, wait a second, here is the shock that's going to get against this ceramic tool, and this is a bad thing. So, I mean, that's a very simple example, but then you could build up, because I agree, Stephen. Now we could, and Russ was even alluding to this, you can look at temperature. Okay, well, gosh, my temperature could get too high. And I know when we're machining, for example, super alloys, and you look at subsurface damage, it's a thermomechanical damage, but it's mostly thermal. So if you can say, I can keep my temperature down. And what's even better, and I'll stop here because I'm sort of getting all the machining stuff, but it's kind of cool, is look, if I can machine at a fast enough speed and get my material removal rates up, we've actually done work where we beat the heat transfer. So I've machined this thing so fast, then you touch the part and it's so cool. And you know what? You can simulate all of that. That's actually not too hard to simulate with all the physics stuff, that you're talking about, Stephen. And all of a sudden now, let's say you tie that into a little bit of artificial intelligence, which a lot of the machines, a lot of the, if you go like to Fusion, or NX, they say start to tie manufacturing, design, process all together. And all of a sudden it can say, hey, if if you can get this feed and speed at this depth of cut, you could use a ceramic tool and not even use coolant because you're beating the heat. I mean, it's pretty crazy where you can go, and it can make that recommendation. You may not even be thinking about it, but it can say, hey, here's my recommendation. So it's cool.
I think there's something. So Russ, I really appreciate you coming on, and you really did a great job of updating me on what you're working on. I had no idea, and I was telling Russ before we started recording that my son majored in digital media because he likes gaming, and you're right, he's not going to be a game designer. But he came to Sandia last year. He spent the summer with me and he interned, and they actually had him using some of those gaming tools, some of the programming tools for training tools, and real high fidelity models for how to manufacture things. So I think I think you're right. I think we're scratching at the surface here. I think if you take that gaming philosophy, you could go down a lot of different rabbit holes here, from something simple like just really high fidelity training tools that are bilateral, where you're getting feedback on, and much like a game, in terms of what you're doing right, what you're doing wrong, to really high fidelity feedback in terms of the controls. I think are there any academics in universities that you see that are really starting to make this connection between the gaming industry and the tools that are being developed and manufacturing?
As far as the specific tool sets I've been looking at over the last, year or so, I haven't come across a huge amount of new publications into kind of emergent offerings. So it's not like you're seeing, NX and Fusion used to not be able to do blah, blah, blah thing, and now they can, and here's how we're going to layer in Unreal Engine. I'm not seeing anything that specific. On the other hand, there is a pretty mature industry in the literature where it's let me use best in class simulation tools and apply that to industrial use cases. So I think the thing that's a gap is you kind of have, let's take tool breakage or tool wear. So that literature has been progressing and gets better and better incrementally every year. Humanity learns more each progressing year about tool wear and chip breakage, or sorry, tool wear and breakage and that kind of thing. So but the path of that research is also more or less stable and has been for a long time. So it's, how do we do better math? How do we process more of the math? It's not really looking for things like, oh shoot, there's a whole new set of variables we ought to be exploring. And that's, I don't know that that's necessarily coming on the visualization side of things. So I want to make it look this way. I'm less concerned with how it acts, but I want to make sure it looks this way. There's a small army of graduate students who have, made a little dashboard for tool statuses, and then maybe they threw an AMR into the project as well, and they've mapped out where the AMR is going to go, and they've shown a virtual space. Now, I think one of the things that I have noticed is there is a lot of research coming out that does that, but it tends to be pretty duplicative. So it's, oh wow, I'm using an Oculus set of glasses to show this virtual reality world, this augmented reality application. But I'm not seeing at the graduate student level, I'm not seeing a whole lot of, good research into prior art, so it's stuff that we knew how to do 15 years ago and 10 years ago. And, what's the piece that makes it novel? Once you get to, postdocs, I think then it starts to see, that's where I think is the place to look out. But I think there's also a tendency to want to get deep into the, show me how this one little piece of math works, right? And, show me how ray tracing applies to, heat. And I haven't seen the seminal paper that says, here's the ray tracing math, here's the heat expansion math, here's how to apply that to machining, right? Like someone will eventually write that paper. I don't know anybody who's really even seriously looking at that at this point. And from my perspective, because I'm not doing, university research and I'm not doing PhD style move the needle of humanities experience, I'm all looking at the integration. So I'm looking at how do these pieces stack up. And I think that's a less obscure piece of the research, but it's also sort of like a less prestigious piece of the research to say, oh, I have to have an MT Connect model for data that comes off the machine, but below that for the tool, I have to have ISO 13399, tool geometry data. And then from there I stack up to, I'm going to layer in some personnel data. And there's this really difficult balance to strike between, I'm doing an integration project and I need data from here and here and here and here and here. And it needs to be applicable and useful and meaningful and able to be transferred to industry in a real way. Versus, oops, I just accidentally decided I'm going to boil the ocean and am trying to simulate everything from, the first grain of sand all the way up to the, to the moon, right? So that challenge of striking the right balance when you're looking at integration research, I think is one of the reasons that there's not more of an obvious sort of body of work developing here. I hope that answers the question, Lonnie.
I think what's exciting though at this point in time is I look at AI, and if you use ChatGPT or Copilot or whatever, I look at, I can tell we use Microsoft Copilot. I can say, hey, write me a program that does blah, 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 blah. And it'll write a program and I can tell what language and the whole bit. I think we're getting to the point. And so Russ, as this progresses along, I suspect what's going to start to happen is you're going to be able to say, hey, Copilot or ChatGPT, I need an interface to do this. So that integration part, somebody's got to initially do it. But I think that integration part is going to start to be solved. And then we're going to be able to say, oh, hey, wouldn't it be cool if I could do this? Yeah, let's integrate it together. So I think it's coming. But by the way, I think it's long overdue and nobody has really put the cycles towards it. But I think it's coming. And I think it's going to be a great opportunity for people to really say, oh, I've got a pretty cool idea. Let's try it. And the controllers that are out there today are going to lend themselves well to it in terms of some of the new generation controllers.
So Russ, have you, or do you know of anybody that's written kind of a position paper on this kind of idea of the synergy between gaming tools and manufacturing, or a roadmap? Is there anything that you can point people to say, we should be looking at this. We should be thinking about this?
Not really. One of the reasons I was doing the research was to figure out if, where do we stand on sort of the market adoption curve? So is this too new? Is it brand new, but likely going to happen sometime soon? Is there already, an existing piece of work like what you're describing? And so I think I'm kind of looking for, where is that going to come from? I don't know that it's going to be me or that I'm going to be driving it. I would be surprised if I don't find it pretty quickly if it comes into existence. But no, I don't think that exists at this point. The closest would be, there's a number of consortia that are sort of in this space. So you have the Digital Twin Consortium, but they're really, they don't have like one, here's where things stand and where we think it's going to go. It's also for all industries. It's also sort of, this is an organization that prior to branding as Digital Twin Consortium was the Industrial Internet Consortium. So they have history and they do go back. Probably the one I've worked most closely with, by way of, trying to tie the MT Connect Institute into this a little bit, was the Alliance for Open USD. So the USD, the Universal Scene Description, this is a file format package that kind of bundles up all my models, all my environments, and lets you, that then gets consumed by some sort of a platform it's going to be building out my physics or showing my visualization or doing rendering or something like that. So Open USD is not, there's the first core spec will be out sometime this fall, and that's the first sort of official community developed version of this thing. But it came out of Pixar. So USD was a Pixar developed tool, 10 years ago, and the intention behind USD originally was trying to animate a movie in a non-sequential way. So instead of doing frame by frame by frame by frame, one image, and you show Lonnie in his office, and then when he turns his head, the background stays the same, but he moves his head, right? Like instead you say, well, how do I make the light in Lonnie's office? How do I make the fabric of Lonnie's shirt? How do I compose this scene up from the different pieces? And that idea of composability for animation was strictly a time saver, right? But in our universe, when we're looking at industrial simulation, that idea of composability is where you get to pull in things like, oh, I really need the materials model, but I don't necessarily need to develop the whole materials model in this platform or package. Maybe company XYZ over here has already done a really robust material model, and all I need is a place where I can slot that layer for material model in, and I've predefined some interactions between, material, it's going to have to interact with light, it's going to have to interact with physics, it's going to have to interact with, pick your other variable. So those organizations are sort of chasing around defining the problem. And I think one of the things that's interesting is I think a lot of the work product is probably going to be mostly commercial by the time it comes out. So I think the idea that you've got kind of umbrella groups saying, oh, here's where things stand about what the internet's going to look like, or here's what AI will be doing for us. I think this is a little bit lower down the abstraction layers into, I want it because I want it to go into product. I want it in product so that I can, do my applications. My application might be running a warehouse robot. My application might be making a movie. My application might be running a CNC machine. So I'm not super, like, I'm relatively happy with the fact that there's not, some grand organization that's identified this and said this is a position statement, because the work is all still pretty aimed at commercialization.
Yeah. I have to say, this is the most thought-provoking discussion that we've had on one of these podcasts.
Well, I aim to provoke, if nothing else.
I'm kind of, my mind is spinning on this a little bit. I think this is really thought-provoking, and I appreciate you kind of telling us what you're thinking about.
Yeah, no, it's awesome. And I know we all appreciate being provoked, but even better if it's thought provoked, right? So, well, this is great stuff. I think we're getting close to our target time, but I was wondering if, Russ, you had any final thoughts, or that you'd like to share with the audience out there, because this is very cool stuff, and what it's going to do is it's going to allow much more rapid, is that right? And it's not rapider, but quicker deployment of new capabilities and concepts and a whole bit. I mean, to me, it's like, somebody comes up with something like tool nose compensation, tool nose radius compensation, which I know has been out there a long time. But when it came out, what is 30, 40 years ago, whenever the heck it was, because I remember using it as a kid, back in grade school, all of a sudden, boom, you have it at your fingertips and you know how to use it, and it's sort of integrated into your system. That's what's going to be happening. I think in, I don't know, is it going to be 3 years, 5 years? But when that time comes and all this starts to happen, it's going to be like, wow, I've taken my shop to the next level. Anyways, Ross, I'll give you the last few words here.
I mean, Tom, I think you nailed it, right? I was at a heavy equipment manufacturer very recently, and I had 25-year-old developers. I had executive who is 3 months from retirement, and I gave the whole dog and pony show about simulation at the request of some members of the team, and 3 months from retirement executive, it's like, no, this isn't going to work. We already have simulation tools. This only works for big companies. Nobody cares. Like, why am I even here? Right. And okay, fair. We do already have simulation, and you do have to talk about what's the specific use case. But Tom, when you say it didn't used to be there, it was being developed, and then boom, it's in your hands. That's how this is going to work, right? So you don't have to know everything about what's going to happen next. If this is of interest, if your wheels are spinning like Lonnie's are, and you're thinking about, oh, well, here's a product angle, here's a use case for it, there's a use case for it, gather those thoughts now and be on the lookout for what the fully commercialized product ends up looking like, because it is absolutely coming. But know that it's going to start out as narrow. So you might be buying some little tower of a point solution type thing, and then eventually you're expanding to a platform, or you're rolling out your own platform. And I don't necessarily see much of an end, right? So it's going to be, we move away from pure physical to some digital to lots of digital. But then, say you build out a really robust machine tool simulation. Well, okay, well, let's add in personnel data. Well, let's add in environmental data. Let's add in the rest of the cell. Let's add in the rest of the plant. Let's add in the rest of the enterprise. It doesn't stop. It goes forever. So I think the only thing you kind of owe yourself at this point, if you're thinking, down this line about trying to be a sort of a leader in the space, understand that there's a lot of work left to do, and timing is going to be everything as far as whether you can be, fully successful and make any money at it, or accidentally make a wrong bet and lose your shirt, right? So it's coming. It's definitely not here yet. This is a little bit earlier in the cycle than I'm necessarily comfortable working on. So I'd like to have send me all your PhD students so that they can do the cutting edge, bleeding edge stuff. I'm here for the commercialization and the money making piece.
So
There you go. Yeah.
Russ, real quick, are you giving any talks on your position? Are you starting to? It sounds like you've gone out to a couple of companies.
I've done like a small circuit on sort of one-to-one with individual customers and collaborators. I spoke at the Alliance for Open USD's inaugural membership meeting. That was really well received. You got people from media and entertainment that have no knowledge whatsoever of manufacturing, much less machining. And, I'm putting a big picture of a CNC machine in front of them and kind of walking them through how I see that being related to what they're already working on. So I think there's the conversation is definitely starting. I'd love to see at big shows or at big conferences that are familiar to us. I want to see more of this stuff kind of being on the table for discussion, whether it's me or somebody else.
Excellent. No, I think that's it. And I'd say it's not only is it coming, but you better be ready to use it, because, it's going to give you that competitive edge, and, it's going to help you be more profitable, more competitive, and the whole bit. And, if you're not using it, your competition is going to be using this type of capability and keeping up the speed, and they're going to put you out of business. So I think it's right on target. Well, hey, Russ, thanks so much for your time and for the update. Very exciting. Now, I mean, it was like getting a triple espresso having this conversation. So it's wonderful. So,
well, 18 months worth of work condensed into half an hour. So that's what you get.
Oh man. Well, I think we're going to have to sort of be kept up to speed on some of this stuff. We'll definitely have to have you back. And I think with that, I will thank you for joining us. And as always, Stephen and Lonnie, great seeing you guys again. And we'll see everybody next month.
Yeah. Thanks a lot, Russ.
All
Thanks so
right.
much for
Stay
having me.
safe, everybody.